there, this is just a quick update on Charlie's power controller for the DC motor. Not much has happened this summer, obviously because it's nice outside and not so nice inside. So we've kind of done a little bit of work on it, but we're leaving a lot of the actual circuit board building and that until the fall. What has happened is that we've managed to get Charlie's donor heatsink trimmed down to the size that we're going to use. This is a little bit bigger than I was hoping for, but to be able to fit 6 FETs and all the caps, it needed to be about 150 millimeters long. So now that we've got that part sort of settled down, the mechanical work can be done to sort out where the location of these FETs and caps and stuff need to go inside. During the schematic entry, I kind of discovered a little hiccup with using my UCD 313-8064 power controller. Now, these power controllers are intended for AC to DC, DC-DC isolated type power supplies. They don't have any motor control peripherals. And that's a problem, since I kind of need one of the motor control peripherals, and that's the quad enclosure, or sorry, decoder inputs. What you need for that is basically an up-down counter, and I don't have one that's accessible in the UCD. So what I'm going to do is put down a CPLD from Xilinx, and I've used these in the past. I've picked up this eval board to develop the code itself for it, but the CPLD, you can program in a 16-bit up-down counter. You can put in a SPI interface, and so you can just read registered. There's a bunch of extra I/O that you can probably use. So it's a useful thing to have. Unfortunately, it's an extra complication in the design. Because of that, I'm thinking of breaking out the digital part of this board to be a little daughter board that I can then just pop off and replace with a different daughter board. Now, TI produces a series of microcontrollers that have like a control law accelerator and lots of peripherals that are dedicated for or suitable for motor control. Now, the particular processor, the Piccolo TMS 320F0049C, that's a big mouthful. That one I'm thinking I'm going to use as the alternate. Now, the reason I chose the UCD originally was because the PID current loop can be done very, very easily. Like, it is so simple to set up in a UCD, and so you're not coding, you're not doing anything other than doing a configuration of hooking up hardware blocks internally. With the Piccolo, your current loop has to be done in software. They've done some things to make it faster, but ultimately it's still a software calculation, and if you hit a breakpoint when you're doing your debugging, that tends to be really bad for PWM bridges that are under current control. It kind of locks the bridge in a certain state, and then you lose control of the current, and things blow up and all that magic smoke disappears, and then you get frustrated and have to rebuild it. So I'm gonna try first with the UCD, and then if I run into problems, then I'm gonna probably switch over to the Piccolo. But I got time, I got skills, so it's all fun. Yeah, I think that's pretty much all for the update. Hopefully we'll have some new stuff coming up in September, showing more of the power board design, mechanical part of it, and how the control board will get plugged in and so forth. So thanks for watching, and stay tuned.